Okay, I can see like 2 people just joined. Hey, hi, hello. Can you hear me? Is it working? Oh, perfect. Awesome. Cool. Okay, so how many people joined too? Let's maybe give it a bit of time. Hey, nice mic. Yeah, I'm planning to actually buy a microphone. I think the sound will be definitely better. How's the sound right now? I did a noise cancelling filter. Is that better? Oh, cool. Awesome. Um, okay, let's wait a little bit. Did you both attend the previous session? Okay, cool. Some people are joining. We have 4. Oh, cool. Okay, that's good. Okay, so let's give it a bit of time. I think I will start maybe in a couple of minutes. Okay, so maybe I can go a little bit around, like just kind of. Hey, hi. Okay, so I'm going to quickly resume what we talked about last week. So I think the session is actually available on Twitch, so people can actually access the previous session. So what we did last week for 1 hour was me going through PyTorch Lightning and explaining how I usually navigate the code base. So we went through the PyTorch Lightning repo, went through like all the different modules, accelerator, callbacks, core, distributed, light, loggers, and so on. And I kind of explained how like a new contributor or like someone who was new to Lightning could go through the code base and try to understand the different components of Lightning directly from the names of the folders or the names of the files. Any question from that? Anything which wasn't clear from the previous session for people who attended it? Okay, 7 people. Cool. Okay, I guess it was clear, hopefully. Okay, so today we are going to do something slightly different. Cool, no questions. Okay, so today, so I think last week we actually didn't fully finish, or maybe I might quickly go through like the missing parts, but what I really wanted to do today is kind of use interactive debugger from Python, built in within VS Code. So going for like the simplest possible models, which is a borrowing model, and see where the code goes. And as we follow the code, I will kind of explain what's happening, how Lightning has been built this way, and if people have questions, don't hesitate to just ping me in the chat. We can stop, we can go anywhere in the code. So if people have, so I will try to stay high level as we start navigating the code base. If people have some interest, like if they want me to maybe follow more the methods within the accelerator side, loggers, anything, please tell me. I will try to do so. Okay, so let's see what time it is. It's for how many people are attending. Cool, we have 9 people, which is really exciting. Okay, so I guess I can quickly get started. Cool. Okay, so yeah, so I did something very simple here. If people want to reproduce that, I'm actually going to copy that code and put it on just one sec. I'm going to put that. Okay, seems I can copy, so just one sec. Okay, interesting. So somehow I can copy in the stream chat. So yeah, that's weird. But anyway, yeah. So if people want to quickly reproduce this code, it should be fairly simple. I'm just importing the borrowing module from PyTorch Lightning test. So like people can just clone the repo, and from Lightning create a simple virtual environment. And then from test, helpers, borrowing model, you can import the borrowing model, which is what we use internally for all our tests. So the borrowing models, I can quickly show how it looks. So it's subclassing the Lightning module, and here we can actually see that it was implemented by Will, yeah, 1 year ago, actually a bit more than 1 year ago. So it has a very simple one-layer MLP. Simple forward function, computation of the loss is also very straightforward. In the training step, we just get the batch, pass it through the loss, pass it through the layer, compute the loss, and return the loss for the optimization. So it's like the simplest model you could really implement, really. And also for the data sets, we have something which is very straightforward. We create like a tiny in-memory tensor, and then we just slice it from it. So we built that model for 2 reasons. The first one was to simplify bug reproducibility. So when people have issues on GitHub, usually they come with their own models and so on. So usually if the bug is reproducible with the borrowing models, then it's simpler for the Lightning team to work on. So it's actually available under this file, PL examples, bug report model, everything that you see here. So when people have a bug, they can just put it through that code and just show that there is actually effectively a bug. But also it's a very fast model, as you might imagine. So like going through, so Lightning, I think has close to 3,000-4,000 tests at that point right now. So having a very fast model that we can train on helps a lot in scaling and making sure the framework is robust. Okay, cool. So any question at this point around the borrowing model? Yeah, if people have questions, don't. Okay, cool, awesome. Okay, let's see if more people attended. Okay, cool. We are 10. That's really exciting. So, okay, so everyone, cool. Everyone familiar with VS Code and the interactive debugger? If people have never really used it before, I'm just going to quickly show what I do. I have this .vs code file. Inside, I have this launch.json file. I'm sure there's better ways. Oh, cool. Yeah, if you can talk about the debugger, it will help. Yes. So here I have this launch.json, and here I just added my demo today, right? So launch, demo, and it's like the integrated terminal within VS Code. So here I can come here, and here I can see Python demo, Python test. I'm actually going to run this one. Also, when I do and implement tests in Lightning, sometimes like just put test here, so I can just debug it in debug mode too. Cool. Okay, so let me launch this one. So when you launch, we can see this small pop-up coming out here, and I've put a couple of breakpoints, nothing really major here. So the code is going to execute, right? And here we can see that this line has been highlighted, which means the code is waiting for me to do something. So I have a couple of options which can be done. So I can skip through, so I can go to the next line, or I can step into, which means I'm going to check the execution and what that code actually does, right? Also here, which is really nice, if people are not really aware of, is I can see the locals from Python, so what has actually been loaded. So I can see like the built-ins right here with like all the special methods from Python. I can see the special variables and so on and so on. And for people who never really looked into it, there's actually a lot to be learned about Python and how things works out just by looking at all those built-ins. Class variables, so we can see that I did in fact import the borrowing model and the trainer, so those are actually made available, and so on and so on. Any question at this stage? Cool. Okay, so someone shared something in the link. So we have someone doing like 100 days of code, if I'm not misleading. Okay, so he's saying that he's quite new to this thing, so I'm going to try to keep it very simple. I know the code in Lightning sometimes can be a bit hard, so I will try to follow one pace here, and if something feels too complex, please tell me. I can try to find a way to rephrase myself to make it more abordable. Cool. Okay, so let's get started, right? So let's quickly follow what the debugger gets us, and yes, cool. Okay, so here I clicked on step into, so I was actually here, right? And I'm going to start being inside of the init method of the brain model, right? So as we will expect, I just got into it, and here I can step, I create my layer, and up we can see that the model has been created, all the method has been executed. What I could also have done is looked into this init method, so I could have, so actually let's do that. So if I want to restart, I can just quickly restart like that. It will get me back to this line. I can step into again and step one more time, and here I'm actually inside of the init module of the Lightning module if I wanted to explore that. So for people who usually want to learn a little bit about a framework, I will advise to do something like that in general for any framework. Like you just put some code and you just follow where the code goes. You don't need to go too deep, right? So you didn't have to go in the Lightning module init method, but if you wanted to, it's also a very simple way to kind of learn what the Lightning module kind of internally keep, right? So here I can see keeps a couple of small things really. That of its init method up. Then here I can see that I finished the init method, so I returned, and now I'm back here, right? So I could have just stepped through. Okay, so what I really want to focus on today are the trainer initialization, because the trainer is really the main component, right? So in the for people who don't necessarily know Lightning, there is three main components: the trainer, the Lightning module, and the Lightning data module. The Lightning module is a component which, as you might see here, really contains your neural network and how to optimize it for training and how to evaluate it for validation and testing, right? So that's really like your research code. The data module, which I think we can see here, is the one which implements the train, val, test data loaders, where you can actually add your data loader. So it's really like a data loader holder at this stage. The entire idea behind Lightning is once you have your model and your data module, you can pass that directly to the trainer, and the trainer will automate entirely the fitting, the validation, the test, and the predict. So what I want to convey today is demystify a little bit how the trainer does all this orchestration by going through the code, quickly explaining how things works. And if people have interest, please tell me. I can definitely get a bit deeper into anything. So I'm going to use this feature from Lightning, which is very useful if you want to test any model really, which is fast dev run, right? So if you want to unit test your model is actually working properly, you just put fast dev run equal true, and that will run on like one batch for fit, validate, test, and predict, right? So you will know that the code has been properly implemented, and if you wanted to train for longer, you could actually do so. That will also deactivate all the extra features like model checkpointing, loggers, and so on. So it's actually simpler if you wanted to execute the code to go forward. Okay, so I'm going to remove this one. So here, by just clicking here, I can remove the, we can see like the dot goes away, which means it won't be activated, or I could also remove it from here directly. Right, okay, cool. So let's go within the trainer. So actually the first time you run the code, you will see that when you run the trainer, you get into this method. The first time I went into Lightning, I actually got confused about this one. So let's quickly search what this one is being called. So I can see this method is inside of the utils, right? And it's actually a decorator around the init method, right? So if people were curious, they could potentially like check the code and see like what this decorator does. But really at the core, it enables users to pass some arguments to the trainer directly through environment variables. So imagine you wanted to pass, let's say like the max epochs. I think you could actually pass it as pl.trainer max epochs, let's say equal 10, and then you will do Python script, and this this decorator will just capture that value when he parse here the environment variables and just capture that. We can actually quickly check that, and here, yeah, that's exactly what this example shows here. Cool. Okay, so let me go back to where I was. So I was here. I'm going to remove that. Sorry for that. Okay, so let's skip forwarding quickly. So here the fn method was actually the one from the method we were interested in, right? So I went too fast. I actually went through that method. So what I can do is, okay, let me just quickly close that. So what I could do is just restart, right? So that will get me here to the trainer again. Now I can step again through it. And here I should also be able to see that fn, right? So if I put in fn, it will actually tell me that's like the method, the init method of the trainer, right? So now I can step through, and now I'm actually within the trainer, right? So I actually completed the decorator and went within the trainer. Okay, so let's go quickly through what the trainer initialization does, because there's definitely a lot here, right? So there is this extremely long list of features the Lightning, the PyTorch Lightning supports through the trainer. I will advise like curious people to actually go directly open this trainer.py and quickly look and read the doc strings. That will already give you a very good understanding of what Lightning has to offer. It's definitely not exhaustive, but that already provide a lot of information on how Lightning, like what Lightning has to offer. So here we can see, for example, that the trainer has a state. We have a utility here which parse the attributes, the arguments the user provided. So GPU, TPU cores. So the GPU IDs are actually the GPU you want to run on. TPU cores are the same thing, but for the TPU from Google. Then we have this concept of connectors. So connectors are a component which enable to connect the trainer to something else within the code base. So it's really like a responsibility handlers. Usually they take care of initialization, right? So here we have one component for datas, one component for accelerator, one component for logging, one for callbacks, one for checkpointing, one for the signal handlers. We have one for the tuner, right? So what I could do here, for example, if I wanted to, is I can quickly go through those, right? And here I could decide I want to go through that. So that's one thing which I'm not a huge fan of in VS Code. Is like I actually need to click on all of those, right? But here I could actually decide now to go within the accelerator connector to see more of what's happening. If I wanted to, I could quickly read the doc string here and go deeper within the code. So I'm going to skip that yet because I still want to have the kind of show the high level view of the design, but if people are interested, I can definitely do so later on. So as I say, like in Lightning, when we look at the code base, is several parts where there's actually a lot of code, right? So if you check accelerators and strategies, which are really related to distributed training, then this accelerator connector is responsible of that. At the core, this component is responsible for taking all the arguments coming from the user side. So everything you could provide to the trainer, parse them out, sanitize that everything has been passed properly, and then create the associated objects which are responsible for distributed training. So in Lightning, there are a couple of objects. So there are the strategies, which are like the high level component. And the strategies requires an accelerator. So here there will be a place where we select the accelerator. There will be a cluster environment if you do distributed training. There will be a precision plugin, which is responsible for handling precision within Lightning. And a couple of extra smaller components like checkpoint.io and so on. So all this logic of instantiation is actually happening right here. The accelerator connector went through a recent refactor, and I think the code now is definitely much simpler to read. So if people have any interest in learning how Lightning does distributed training, that's the place to start from. The next place is Logger connector. So this one, as you will expect, is a component which connects the trainer and the Lightning module to all the logging, to all the loggers. So here in Lightning, we have a couple of loggers, TensorBoard, Neptune, 1DB, and so on. And this component is going to be the interface to manipulate all the logging parts. So then we have the callback connector, we have the checkpoint connector. So here we could have potentially thought that the callback connector could have also handled the checkpoint, right? Because in Lightning, the checkpointing is implemented through a callback, which is model checkpoint, right? But it's actually quite a big, it's actually a massive thing in deep learning in general, right? Like checkpointing is such a complicated thing that it deserves its own kind of connector, its own encapsulated logic. Then we have the signal connector, as I said a bit before. We have the tuner. So the tuner is responsible for two things really in Lightning. I mean, it has two primary features, finding the ideal batch size, so like the bigger batch size you can fit on your machine, or finding the best learning rate to start your training. So then we do a couple of extra things here. We parse all the kind of min step, max step, epochs, max time you want to provide to Lightning. So that's actually how many epochs or time you want to train your models. And from those, we are going to create a couple of loops. So we have a fit loop. So fit loop is really the one which is going to be called when you call train.fit. And here we can see that, so the entire idea behind loops was we want them to be composable, right? So someone might come and say, I have a specific use case where I want my loops to have a different behaviors. That's something which is entirely possible right now in Lightning. We have an abstraction right here. So we have this base loop, which really implements like the concept around like a while loop, right? So it's something like that, like while not done, then you do something and you advance and on advance end and then you finish. So the idea is in Lightning, all the loops have been implemented in this way. So for fitting, we have the fit loop at the top, and this one contains like a training epoch loop, and basically they're just blocks which can be composed with each other. So if users wanted to, they could actually customize Lightning to its core by introducing like quite advanced behaviors. We have actually a couple of examples in PL examples, which I think can be found under loops example. So we have this, for example, this scaffold loop will show how to do cross-validation with Lightning. One where you could implement your own training with pure PyTorch by the loop API if people wanted to. And here is a kind of more advanced one where you could add support for the training step to actually yield the loss instead of returning the loss, meaning you could compute multiple loss and do some kind of smart memory optimization for GANs. So here we can see that the loops are being composed with each other. Here the trainer is being assigned the fit loop. It's being assigned evaluation loop as a validate loop. Same for the test loop, and it has a prediction loop. Any questions so far? Anything confusing? Okay, let's see if okay, not yet. That's great news. We can see 12 people. That's great. Okay, so let's keep going. So yeah, so here we have the checkpoint paths, the paths which are actually used to and we can see that they will actually be removed in Lightning 1.8, which is in 6 months from now. So in Lightning, we try to follow PyTorch releases. So we release, can you give me an example when yield is useful? Yes, so I think we have actually, okay, so just to answer that questions, so if you check the loops, I think we do have an example. Actually, let me see where we put that. Loops. Yeah, so this is great page in the doc. Maybe I can share that. Hopefully I can. Let's see. Okay, so somehow I can't copy. Okay, just making a test here. I can write, but I can't. Okay, whatever. Yeah, so this is this example here in the doc where Okay, let me see if I can find it back. Yes. Hopefully it still is on. I can find it back. Yeah, so here was the example, right? So here in the loop example yielding training step, we have the place where you implement actually the yield loop, which means that now in your training step, you could do something like that, where you yield the loss once and then you yield the loss twice. And if you were to implement again, there's some operations that you want to do once, for example, like computing the embedding space of your images, which means that instead of computing that twice, you will compute it once, and that will provide some good speed up. And code-wise, it's actually quite nice because once you have implemented that loop, then you just need to connect it to the batch loop of the fit loop, and you can fit it, and now you have this very nice way of implementing your training steps. So yeah, there's definitely a lot of ways for people who wants to customize Lightning for their needs. Does that answer? Okay, cool, perfect. That answered your question. Okay, I'm going to close that. Yeah, and I think actually there is this. Okay, let me see if I can find this. Not Nicki Minaj. This. Okay, no. So I think to remember that. Yeah, so Nicki is a great contributor. He has been working primarily on torch metrics for people who are not aware of his work. Yeah, definitely amazing work on the metric project, one of the primary contributors right here. So I think to remember, he released this very exciting, which is PL cross. So he actually implemented a full cross-validation implementation extension for Lightning, where you can just do like trainer cross-validate or create an ensemble and so on, which is actually built out of the example we have in Lightning, where he created like a custom loop, which is a cal fold loop, which basically just implements all the cal folding mechanism, which means that he customized Lightning for his need. And here we can see that he made some small extension to Lightning to just support all of that. And at the end, now you have a trainer with like enhanced functionalities that you can share among your team. So yeah, definitely some very cool stuff here. Okay, so I was here, went through the loop quickly about the fact that people can customize them. I'm going to keep going. So here we have actually a couple of things happening in Lightning. So every connectors has a on trainer init method. So I'm going to show this one, for example, for the callback connector. So the idea is they have a reference to the trainer. They take a couple of arguments, and here they're going to basically set up the trainer, right? So that code used to be inside of the trainer.init, but it was extremely hard to read. So we just reorganized everything inside of connectors. And here we can see that this one has methods to kind of really do things around every possible callbacks we have within Lightning, right? So we see, for example, this configure progress bar is actually being called here on trainer init. And if based on the arguments the user provided, that will automatically create, for example, the progress bar if it's not available, and inject it directly inside of the callbacks of the trainer, right? So by default, you will create a TQDM progress bar, and I think there's some work in Lightning right now to add support for a wish progress bar. I mean, to be added automatically. Any questions so far? Am I going too fast? Okay, I guess it's fine. Okay, so then we have this other concept in Lightning, which is very, okay, speed is fine, that's great. So then we have this other concept in Lightning, which is called hooks, right? So for people who have used Lightning a little bit, you might know that we have callbacks, and callbacks are just a very small unit of code which can be called at a specific time, right? So you will have like on train start, on epoch start, on validation start, on epoch end, and so on, right? So actually the full list of callbacks can be found under this base.py file for the callbacks, right? So you have, let's say, you could have on epoch start, on epoch end, and so on. So here the idea is when you see this thing in the code, like hook like that, right? It means we are going to go through all the callbacks within on the trainer, so all the callbacks provided, and we are going to call that specific hook, right? So now all your callbacks on its start method is going to be called, which means that as a user, if you wanted to, let's say, customize Lightning, create a new loop, create a new type of callback with a new hook, you could do something similar like that, where you could actually call your on hook, right? Here I could say call my on hook, and here on the base method I could have something similar, which is def my on hook. And now if you were to subclass that and put some code here, that code will be executed, right? So you will get code. Okay, so let me remove that up. So I'm going to revert it back to what it was. So let's keep going. Actually, maybe quickly look into what that does. Yeah, actually, there's a couple of logic here. Yeah, so here we can see it goes through all the callbacks and recursively calls them, right? Provides the arguments. So here it just goes through all the callbacks, and actually we can see that by default, Lightning already injects some callbacks. So there are four callbacks. So we have the TQDM progress bar, which has been already injected. There's a model summary, which is injected by default. There's a gradient accumulation scheduler and the model checkpoint, right? Which are just injected by default. And all of that is accessible under trainer.callbacks. Okay, so let's keep going. So now we are going to initialize the data connector. Same thing, something specialized for the data. Up, so let's pass that. Here, a couple of depreciated arguments. So let's go forward. So here it's really a lot of check. Like if I was to, like, I think one thing that someone could, for example, do like as a first simple PR is to actually clean this code and move that under utilities, because if you're like a new comer to the code base, that doesn't look very good. It's actually a lot of code which is not really essential. I mean, it is essential to the code base, but it's not like an high level piece of code, right? Like that's definitely a high level piece of code. Like it does way more in the back, but it's very readable. You know, like data connector gets actually initialized, but that's definitely not high level. So let's keep going. A couple of extra things here, a couple of setups. So let's keep going here up. Setup on init, so a couple of extra things. Here we can see the tuner gets initialized. Here we initialize also the profilers. So in Lightning, we have actually 4 different profilers. The simple profiler, which just times the method's execution. The advanced one, which is, I think, relying on C profiler. And then the PyTorch profiler, which is built out of the Kineto profiler. And then one which is specific for XLA. So when you want to learn a bit about the framework, I usually find that going at that pace, like really kind of going through the debugger, like not necessarily diving too much inside of the code, like really following the high level, like already provide a lot of interesting knowledge around how the framework has been built out. Yeah, so here we can see the logger connector doesn't do too much. It just, okay, here it configures the logger. Okay, so here we can see that it will try to inject TensorBoard logger directly inside of the code base if logger was to be a Boolean, right? So if you were to say trainer logger equal false, no logger will actually be added to your code base. So let's keep going. So a couple of debugging flags. So that's where the fast dev run is going to be utilized. So up. And here we have the on init and hook of all the callbacks which is being called, right? So we went through the trainer init method, so I can just remove that breakpoint and we can go to the fit method, right? So now our model is initialized, our trainer is initialized. It's time to dive into the fit method. Any questions so far? All good? Okay, I guess so. Let's see if people are still there. Yes, 12 people. That's actually quite amazing. Cool. Okay, so let's diving a bit into what's happening, right? So we can see that when you call the fit method, it takes actually a couple of things, right? So it takes a Lightning module, some data loaders, which is actually optional. You don't have to pass them. A val data loader, a data module, and the checkpoint path. Right. So if we quickly look at and read what's written here, the model is used to be fitted. It's a collection of data loaders, nothing really crazy. Also, here you can provide a sequence of data loaders for validation, so you can test on multiple data loaders. You can provide the checkpoint path, which is used to reload the model and the data module. So again, what I would advise for people who usually try a new framework is, as you develop stuff and use the tools, like I would advise to always at least go to the definition of the methods you use, so you have a slightly better understanding of what's happening here. At least, like, instead of going to the doc, look at the DOS string. Like that should give you all the information on how to use the thing, and also you might discover that, oh, there was this parameter you never knew about, and you can actually use it and you can know what it's been used for. Okay, so let's quickly look at what's happening here, right? So here we have the strategy, right? So let's actually put it here. So let's look at what's inside, right? So the strategy is, which has been selected, is a single device strategy. It has an accelerator, which is a CPU accelerator. I don't have any GPUs on my machine. It has a torch checkpoint IO, which means it's actually going to use and store models using the utils from torch. It's running on global rank 0, so by default the rank is 0 unless you do distributed training, and then each process will have a higher rank from 0 to the word size -1. It's actually the global rank 0. It doesn't have any launcher. It doesn't have a reference to the Lightning module yet, so that's something which is going to be done actually right here when we run that line. Yeah, and here we can see that, yeah, this component is going to be the one owning the optimizers, optimizer frequencies. Yeah, so just here, like by looking quickly at this object, you already get a good understanding of what it's supposed to do, at least at some high level, right? So you don't necessarily know how it's implemented, but at least knowing what it owns gives you a lot of information. So here we can see this thing which might sound a bit strange for a lot of users, but we have this call and handle interrupt, and we pass a method inside of it, right? And in Lightning, this method, as we might see, is being called in multiple places. So it's actually called also for validate. It's called for test, and it's called for predict. And this method is actually there to ensure that when you launch the method, so when you launch a fit or something, if any errors was to happen, like any exceptions was to be raised, then Lightning can gracefully exit, right? So if a keyboard exception was raised, then here we will run those specific hooks. If a specific exception was to be run, same thing, we will make sure that we tear down properly, everything is done properly, and we exit. Cool, so let's go and keep going. So here so now actually I can check and I should see the Lightning module reference. Why was it? Yeah, not yet. Okay, so cool up is going to get inside of the, oh, actually, okay, so that's a great example where I went a bit too fast, right? So what you could do is you just go there, you remove this thing here, and you just relaunch it. All right, so oh yes, I had this one here, so here I can continue up, and now I can get inside up. Cool. Okay, so I think it gets here, and here I can get inside of my fit implementation. So this one is really the method which starts the fitting, right? So what we do here is we do some preparation. We say to the state that the fitting starts, that we actually start to run. Here we are going to actually parse the arguments provided by the users. So we get the data loaders, the data modules. We attach that we attach that to some objects internally to keep track of those objects, and that's handled by the data connector. We get the checkpoint path, and then we call this run method. So the thing which is actually interesting is this run method is being utilized by all the entry points, right? So like predict up. So let's quickly check. So the run method is actually, yes, used by all the methods, like the feed, the validate, the test, and the predict. So in Lightning, we managed to get all of them aligned internally. So I'm going to get inside of that. Okay, cool. So now I'm actually inside of the run method. So this one is really the one which is going to launch the training at the high level, but prior to that, it's actually going to do a lot of setups. All right, so I'm going to go through that setup, like try to answer questions if anyone has any, and if I'm going too fast, please tell me. Like this, I will say this run method of the trainer is one of the most important in the entire code base, and that really tells you like all the execution of the code at the high level. Okay, so the first part, like the first thing we actually do here when the run method is run is we are going to connect the Lightning module. So here, if I checked, I should see my borrowing module, which is my Lightning module, and that's going to connect it to the strategy. So I can quickly check what this thing does. Nothing really crazy, it just attach it as the module. So I'm going to pass that. Now the strategy is aware of the module. So if I print that again, I should see that if I check for module, I should actually see it somewhere. Yes, I can see that now he has a reference to the borrowing models and everything the borrowing models is, right? The next step is to rely on the connectors to do some connection, right? So here, it's actually possible to, for the Lightning module to provide some callbacks. So if the Lightning module implemented a configure callback hook, we could get those callbacks and just add them to the trainer callbacks. Now we have the attached module Lightning module function right here. So here it's actually quite interesting. We are relying on the Lightning module log method and attach it to the callback, so you can log directly inside of your callbacks. It's definitely a bit of a hack. It's not the cleanest way possible, but that make it simple to handle. In this method here, we have a lot of validations. So I'm going to browse very quickly around this one. Like it really validates a lot of things around the trainer model definition, right? So it could be something that, did you actually implement a train data loader, right? Did you did you do something around the progress bar? Did you do anything, right? So all this logic of checking is going to live in this kind of big utility file, which does all the validation. So now we know that when this line is passed, that everything has been properly implemented, we are good to go. And here we have this thing. So here it's going to say prepare. So we have this thing here, like prepare datas. Now we are going to get into a part which is sometimes a bit confusing for a lot of users in Lightning, which is around the preparation of data. So I'm going to quickly explain how this thing looks like. So when you implement, let's say, a data module, right? So if you implement your own data module, you have really like two hooks you care about, right? Which is prepare data and setup. All right. And here's my own data module, right? So let's think it this way. So imagine I have like a ImageNet layer, maybe like my CIFAR, because, okay, cool. My CIFAR 10 dataset, right? My data module. Okay, cool. So in Lightning, we have those two hooks. Okay, just one sec. I'm just adding some blah blah here so I can explain things simpler. Okay, cool. So here's how it works, right? So in terms of execution, when the data module is being passed, right, we get something where first we are going to call prepare data, and then we are going to call setup, right? And then from that, we can actually have something internally which is going to do, which is going to then call the train data loader, and from it we can actually access the train data loader. When you implement your data module, usually at some point you might want to download some data. And if you were to run this code with distributed training, it means you are going to launch like n processes. And all the processes are going to run the same code, which means that they're all going to run this prepare data method. And they're all going to start downloading the data and override each other. So instead, what you would like to do is something like that, which is if rank 0, then call prepare the data. If not, wait for rank 0, right? And that's something that Lightning does automatically for you, right? So when you implement prepare data, that hook is going to be called only on rank 0. So your data gets downloaded, all the other ranks are going to wait for it to finish, and then you can do the setup, prepare your data loaders. But now, like all your data, like all your processes have access to those data which has been downloaded once. Is that clear? Anyone needs more information about that? Okay, good. Okay, I'm not sure if that was clear enough, but yeah, that's really where the logic happens. So I know it might sound a bit blurry, but at the end, it's really what it does. Like we are checking the local rank, the global rank. One small thing to know here is when you do distributed training, when you start usually doing so, you have only one machine. But when you want to scale, you don't have a machine with like 1000 GPUs. You have a lot of machine with 8 GPUs, which altogether adds to 1000 GPUs, for example. So you might need all the datas to be available on each node locally. And it's why here you can have this prepare data per node, which is an attribute of the data module. And here you could say equal true, and that will just say, okay, so if local rank equals 0, right? So like the local rank of my node, then that will be called, and all the others will basically wait for this one. Okay, let's see if people are still there. Okay, some people are leaving, which is entirely fine. Okay, so let's keep going. So here we can see that we did prepare the data. Now, like my data are downloaded, are available on my machine. Here I'm going to call a couple of hooks, nothing really crazy here. So here we have a very important hook for like a very important call for distributed training. So okay, one question. So for all the nodes with each GPUs, prepare data runs on all the nodes, like 2 nodes with 8 GPUs. That's a great question. I would assume that by default, Lightning is going to run the downloading on the rank 0 of each nodes, right? So maybe let me quickly draw that, right? So imagine you have 2 nodes, so node 0 and node 1, right? And this one has GPU 0, GPU 1, GPU 0, GPU 1, right? So if you were to say, for example, trainer name nodes equal 2, so you have 2 nodes, right? 2 machines, and you were to say, actually, what will you say here? You will say, I guess, GPU equal 2. It means in total you want to train on 4 GPUs, right? That's like number of nodes multiplied by the number of local GPUs, right? So if you were to do that, what you will actually get is the following, right? So you will get, so let me have it as a table quickly, right? So up GPU 1, GPU tag. So you will get node number, GPU number, local rank, and global rank, right? So here what you will get effectively is, let's say, here you have the first node, the GPU 0, is local rank will be 0 and its global rank will be 0, right? So this one is the global rank 0. Like this one will be the one to actually be responsible for logging. Then you have the second GPU here, which is going to be local 1, global 1, right? And then you will have on node 1, this one which is the local GPU, which locally is 0, but globally it's number 2, right? And then you will have this one on the last one, which is basically the GPU 1, local it's 1, global it's 3, right? Which means that you have 4 GPUs in total, ranking from 0 to 3. Locally you get 0, 1, 0, 1, and the node ranks are 0, 0, 1, 1, right? So effectively, when you download your data, you want your data to be available on the first node and the second node, but you want only one process on this node to download the data. So that will be the responsibility of local rank equals 0. So this GPU and this GPU. Is that clear? Does that answer your question? Oh, cool, awesome. Yeah, it's not like I think like DDP is somehow like seems complex for a lot of users, but I think if you just kind of have it like just writing down in the way I do, right, it's actually quite simple. And then if you wanted to add more nodes with 2 GPUs, and just like the same thing, right, like here just 1, 0, 1 like to the number of machines, and here you just keep increasing the rank, right? So nothing really too complex here. Okay, so let's keep going. So here this one set up the environment, and if we really look at what setup means, so let's actually look at the strategies and maybe DDP, because we were talking about that, right? So if all the nodes have access to a common data server, then will be the downloading to us. So yeah, so that's a great question, right? So I think what you need to ask yourself is the following, right? So it's like, so you have 2 nodes, right? So 2 nodes. So I think you have 2 cases here. The first case is a file system shared, right? If it's shared, then only rank 0, so only global rank 0 is going to run prepare data, right? But that's actually not usually what happens in the cloud. So if you have something in-house where it's actually true, maybe if you work on a cluster where the nodes actually have the same file systems, then yes, it will happen this way. But most likely it's actually, so if that answer is yes, right, you get that. Otherwise, if the answer to that question is no, then that will be run on local rank 0 is going to run the data, right? So here it's basically 2 processes are going to run it, and here it's only 1 process. Does that make sense? And also one thing I forgot to mention is Lightning has an internal mechanism to detect that. So what it's trying to do is, like, the global rank 0 is going to save a file, and then it's going to ask to all the other processes, do you see that file? If they see that file, then it means it's a shared file system. So only global rank 0 we call prepare data. Otherwise, it will be local rank 0. All right, so like Lightning just has the ability to know and answer that question and just automate all of that for you. Cool, awesome. That's great. Okay, cool. So I was on setup environment right here. So yeah, let's quickly look at what DDP does here, because I think it's actually quite interesting. So okay, so when you call DDP setup environment, it does a couple of things. So first, it's going to call this method, which is setup distributed. And here we can see there is like 3 methods, right? Set word ranks. Oh yeah, it's a very cool feature. Yes. And I think sometimes, and I think it's why as users it's good to go a little bit through the code base, because Lightning is a accumulation of, I think, like 600 people knowledge, right? And very often I have ideas on things which could be implemented into Lightning, and then I go through the code base and someone had already this idea and implemented it. And I think that's kind of automatization is exactly what boilerplate looks like, right? Is it a file search system? Like, should I download my data once or twice, right? That's what a framework should do for you, right? It should just take care of all these boilerplates, so you don't even have to know about it. It just happens under the hood and does it properly for you. Cool. So I was on setup distributed. So yeah, a couple of very interesting things here. So here you see, as I was saying, like you do have a node number, which is called node rank, usually, right? You have a GPU number, but that's something you don't really care about. That's something you do when you get NVIDIA SME. But what you really know about is a local rank and global rank, right? So it's actually where this thing comes into life, right? So it's actually here that you get those. When you check the set word ranks, you will see that the cluster environment is the mechanism which is used to know about that. Actually, I might have jumped one thing, so I just want to check. Oh, yes. Okay, so Lightning changed a little bit recently. So there's one thing which I didn't talk about, which used to be there. So now it's actually under the launchers. So Lightning now has what we call launchers, which actually create the processes, right? So here we have this sub process script, which is responsible to, from global rank 0 or local rank 0, to create all the other ranks. And here we can see that what it does really is create the node rank, like pass as environment variables to the subprocess node rank, local rank, and just create the process with it, right? So it's going to actually inform, like create the processes of the global rank and local rank, right? And that's how the entire thing is working, because each process knows what its responsibility is in the code, right? So here, yeah, setup distributed, and this one is using the environment variables to kind of set the ranks and so on. And then the next step is to initialize the TCP stuff on PyTorch. So in PyTorch, you have these methods to be called when you do distributed training, which is torch distributed init progress group. And to it, you provide your rank and your word size, right? And that's really the information which enables all those processes in PyTorch to communicate with each other. Which means that each process is aware through the cluster environment of its own rank and the total number of processes to be run on. Any questions so far around this part of the code base? Let me see how much time is left. Okay, cool. Okay, I guess no questions. Okay, so one thing which is very interesting to notice here. Okay, so this init takes care of all the TCP connection. Yes, exactly. So what this thing does, it's going to initialize. So it's going to make it available and initialized. And in PyTorch, you have this TCP. Let's see if I can actually let's have a look directly in the code base, right? So if you check in Torch, you will see Torch distributed. Where is it? Here, right? So you get here, and here you see, okay, what was the name of the method? It would be simpler to find it this way, right? So you get, yeah, so it calls this method, right? And this method gets the backend and so on and so on. And here you will see that it creates a backend, a progress group, and here it creates a store. So let's quickly check where it creates a store. Yeah, I didn't look at this code for some time now. Okay, so let's see if I can find. Yeah, actually, yeah, you have multiple ways of doing the thing. But yeah, all the logic is really living in this part, and that's why you get all the communications, and that's why like you get all the reduction or communication mechanism. And actually, I think it's in this file, like the store. So yes, if people are interested, that's actually where some of that logic is being done. Here we can see the TCP store, which is fully implemented in C++, right? So that's where all this kind of entire communication is being implemented, where you get all the utilities, right? So you can broadcast tensors from one rank to another, or from one rank to all others. You can all reduce, which means you can take a tensor on each machine and sum them up and get the summation to all, and so on and so on. Yeah, so that's where all the magic happens. And also one thing you might have noticed is now we get all ranks which have like all processes have a different rank, right? And every process, especially the rank zeros, are going to be given more responsibilities. So one thing which is sometimes very complex when you do distributed training, which is really like why distributed training was a pain prior to Lightning, was if you were to do something like that, right? So if you were to, let's say, in Lightning, imagine there were a bug, and you did something like that, which is if that, then do something like that, right? So let's say if TAC, you wait for rank 0, right? So imagine your code was to look like that. So here, when this code runs like rank 0 is going to say, oh, that's false, and continue to run, right? So it's going to keep going in the code base. But all the other ranks are actually have a local rank which might be different from 0, and they're going to wait. And now what you actually get is a process divergence, which means that some processes are going to wait for an answer which they are never going to receive. And that's why sometimes in very complex systems at Lightning, in the past, there was this thing where you could get your process hanging, for example, when a checkpoint was being saved, or even race conditions for this kind of thing, for this kind of thing. And it's why distributed training used to be very hard, because process divergence can be extremely hard to debug. It just means like processes are not running the same code, and maybe one is running something because it's rank 0, and someone else is like another process is running something else, and it's definitely very hard to debug. Okay, cool. So actually I went, there were definitely way more to cover. I'm running out of time, so I think I'm going to call it a day. I hope it was still 10 people. That's quite amazing. So I think I will call it a day. Maybe we might, if that's in people's interest, I can definitely have another sessions where I just finish this part of the code base. I think we went to here, setup environment, and I can potentially in the future go through the rest and quickly explain at least what happened here at the high level, and if people are curious, they can go into any of those functions and kind of dive deeper into how Lightning does things. Cool, I'm going to close that. Any questions, anything people want for me to answer before I call it a day? Okay, one would be great if we could cover the dispatch method and the next thing next time. Yeah, 100%. I think, I mean, the part which I definitely didn't cover is, I think actually I will, I thought I will go faster today, but usually going through Lightning takes, there's so many things to say that sometimes you get into the details. But yeah, what I wanted to really cover was like the dispatch here, and showing the train method, and how we actually call the feed loop and how the feed loop executes. So yeah, something which I will cover next time. Hopefully there will be a lot of knowledge for people who wants to better understand Lightning abstraction, but also want to contribute. So yeah, thank you a lot for attending the chat, and yeah, see everyone for another session. Bye. Thank you a lot.